This video is about identifying independent and dependent variables, writing a function rule from a given situation, and using a function rule to analyze a given situation. So, remember yesterday we talked about the two flower shop, roses are red, and flower power. So, to make money, the soccer team plans a special project to take orders for roses and deliver them on Valentine's Day. The team found two shops, Roses Are Red and Flower Power. Roses Are Red cost $20 for the service charge and 75 cents for each rose that is bought. Flower Power sells the roses for a service charge of $60 plus $50 per rose. So let's complete the table to figure out the cost for Roses Are Red. So in our table, we started numbering the roses. We have 12, 24, 36. Let's just go by 12. So we have 48, 60, and instead of X, we're going to call this R because R is going to stand for roses. So in our process, remember that we are paying a $20 service fee plus 75 cents times each rose. So in this first one, we have 12 roses. So we would have 20 plus 0.75 times 12, which would get us $29. In the next row, we have $20 plus 0.75 times 24. 20 plus 0.75 times 24 would get us $38. In the next row, 20 plus 0.75 times 36 which would get us $47. In the next one, we would have 20 for the service charge plus 0.75 times 48, which would get us $56. And in the last one, for 60 roses, we would have a $20 service charge plus 75 cents times 60 roses. And that would get us $65. Now, in the last row, for R, we want to make a rule to figure out how do we figure out the cost of roses every time. So we are paying a $20 service fee plus 0.75 R, where R is going to stand for the number of roses, and that's going to get us our cost. So we're going to call that C, because C is going to stand for cost. So if we look at the three columns, we notice that the $20 always stays the same, but our 75 cents is multiplied by the different number of roses. So when we look at the three columns, the service charge of $20 remains the same. The two things that change then are the number of roses, which then changes our cost. So the total cost and number of roses changes. So for our function rule, we can use this last row here to write our function rule. So for our function rule, we're going to have R, that stands for roses, and C, which stands for cost. So our function rule then would be that cost equals 20 plus 0.75 R. Because for every rose that we order, we're paying $20 plus 75 cents. And then we're figuring out our total cost. So now we can use this function rule to figure out how much our 30 roses is going to cost. So we're going to put 30 in for R to figure out our cost. So we would have C equals 20 plus 0.75 times 30. We can type that in our calculator, 20 plus 0.75 times 30. And that would get us a cost of $42.50. Now, in the second part, saying how much roses could I get for $100? So I'm going to take 100 and I'm going to substitute in for the cost value, because this time I want to find the number of roses. So we would have 100 equals 20 plus 0.75 R. So we can subtract 20 from both sides. 80 equals 0.75 R. And then we can divide by 0.75 to get that our roses would equal 106.6. And because we can't, 0.6 repeating, and because we can't get a partial rose, we could buy a total of 106 roses. They're not going to round up to 107 roses because we don't have enough money and they're not going to give us the rose at a lower cost. Now let's do the same thing looking at flower power. Now remember that flower power had a higher service charge but a lower cost per row. So let's fill in the rest of the roses going up by 12. So we have 48 and 60. So our service charge for flower power was $60 plus 50 cents times the number of roses, so 50 times 12. So we have 60 plus 0.50 times 12. That gets us $66. Then we have 60 plus 0.50 times 24. Which gets us $72. Then we have 60 plus 0.50 times 36 roses. That gets us 78 roses. Then we have 60 plus 0.50 times 48 roses. That gets us $84. We have 60 plus 0.50 times 60 roses. That gets us $90. Now remember that we can put any number in for roses, so we can call that R. So we would have a service charge of 60 plus 0.50 times the number of roses is equal to our cost. So our function rule in this case then would be C equals 60 plus 0.50 R. So now let's use that function rule to evaluate a couple of things. So first we want to figure out how much would 30 roses cost. So we're going to put 30 in for R to figure out our cost. So we have C equals 60 plus 0.50 times 30. So that would get us a cost of $75. Then we also want to figure out how many roses could we get for $100. So this time we're going to put 100 in for cost and we're going to solve for our number of roses. So we have 100 is equal to 60 plus 0.50 R. We can subtract 60 from both sides, so we get 40 equals 0.50 R. We divide by 0.50. We would get that R is equal to 80, so we would get 80 roses for $100. So remember we talked about this yesterday, that our cost of roses is going to depend on the number of roses in an order. Each number of roses is always going to give us a unique cost because each different number of roses gives us a different cost. So in other words, the cost of the roses is going to be a function of the number of roses. Remember then that when we talked about an independent and dependent variable, the thing that happens first is our independent variable. So that would be the number of roses. And our dependent variable is what happens because of the number of roses, which is our cost. So when we write our dependency statement, we would say that the cost depends on the number of roses. So let's rewrite our two function rules. So roses are red. Remember we said that the cost is equal to $20 plus 0.75 R. And for flower power, our cost is equal to 60 plus 0.50 R. So let's look at which store would give us the better value if we were buying
75 roses. So roses are red would cost us $20 plus 0.75 times 20 roses, or times 75 roses. So in our calculator, 20 plus 0.75 times 75 would give us a cost of $76.25. Flower power is going to be $60 plus 0.50 times 75. That would give us $97.50. So roses are red would be the better value. So we would say roses are red by, then to figure out how much the better value is, we're going to subtract the higher price minus the lower price to say that it is cheaper by $21.25. Now what happens if we were buying 250 roses? So at roses are red, we would have 20 plus 0.75 times 250. For a cost of $207.50. And then we also have flower power, which is $60 plus 50 cents times 250 roses. That would give us $185. So this time, flower power is better. And again, we can subtract our costs. So 207.5 minus 185 would give us flower power is cheaper by $22.50. Now let's look the other way. What happens if we are buying $200? So if we walked into each store with $200, who's going to give us more roses? So for roses are red, we're going to set 200 equal to 20 plus 0.75 R. We're going to solve for R. So first we're going to subtract 20 from both sides. 180 equals 0.75 R. Divide by 0.75. 180 divided by 0.75. That would give us 240 roses. Now, if we look at flower power, we have 200 is equal to 60 plus 0.50 R. So I can subtract 60 from both sides. 140 equals 0.50 R. We divide by 0.50. We get that our number of roses would equal 280. So we would choose flower power because we get more roses for our money. Now let's look at a different situation. So your sister has a savings account of $1,050 and is able to save an additional $20 per week. So let's figure out our number of weeks. Let's start at 0 weeks, 1 week, 2 weeks, and 3 weeks. So at 0 weeks, she has $1,050 in the bank, plus she's saving 20 times 0 weeks, which would get us $1,050 saved, which makes sense. This is what she's starting with. So at 0 weeks, she would have her initial money saved. Then at 1 week, we have 1,050 plus 20 times 1 week. That would get us $1,070. Then for 2 weeks, we would have $1,050 plus 20 times 2. So 1,050 plus 20 times 2 would get us 1,090. And then the last we have 1,050 plus 20 times 3. So 1,050 plus 20 times 3 would get us $1,110. So to write a function rule, we can figure out what we're trying to do. So we know that we are saving weekly. So we'll use W for weeks, and we'll use M for the money saved. So if we're trying to figure out the money saved, we're going to say M equals, we know she started with $1,050 plus she's saving $20 per week. So in this case, remember the independent variable is what's happening first, so that would be the number of weeks. And our dependent variable then would be the money saved. So our dependency statement would be the money saved depends on the number of weeks. So how much money would your sister have saved after 10 weeks? Well, if we said our function rule was money equals 1,050 plus 20 times the number of weeks, so 20 times 10, 1,050 plus 20 times 10 would get us the money saved of $1,250. Now let's look at your brother. So your brother has $525 in savings, but he was not able to find a job this summer, and he's been spending $35 per week and is enjoying his summer of leisure. So while he's relaxing all summer and spending his money, we want to figure out what's happening to his money. So at 0 weeks, 1 week, 2 weeks, and 3 weeks. So at 0 weeks, he has $525, but he's not saving it, he's spending it. So when you are spending, you are subtracting that away from your total. Minus 35 times 0. So we have 525 minus 35 times 0, which gets us 525, which makes sense because we haven't spent any money yet. Then the next week we have 525 minus 35 times 1. Remember, it's still minus because we are spending the money. So 525 minus 35 times 1 means that he would have $490 saved. Then we have 525 minus 35 times 2 weeks. So that would save $455. And then last we have 525 minus 35 times 3 weeks. So he would have $420 saved. So again, we're going to use M for money saved and W for weeks. So to write our function rule, we would have the money saved is equal to 525 because that's how much he started with, minus $35 per week. So remember the independent variable is what's, so that would be our number of weeks again. And our dependent variable would be what's happening, so the money that is still saved. So our dependency statement then would be money saved depends on the number of weeks. So how much money will your brother have after 18 weeks? So we're going to say money is equal to $525 minus 35 times 18 weeks. 525 minus 35 times 18 weeks. And that would get us negative $105, which actually means he would owe $105 because he's now gone into the negative. So when you have negative money, that is something you then owe. So let's look at one more situation today. Bam Bam's Workout World has discounted their workout plan. They charge $50 for a one-time fee and then $10 every time you visit. So we are looking at the cost
which we're going to call C for cost. And it's going to depend on your number of visits, so we're going to use V. So in our function rule, we would have cost equals. We're paying $50 to sign up to join the gym, plus $10 for every visit. So plus 10V. So how much would it cost for 90 visits? So our cost is equal to 50 plus 10 times 90 visits. 50 plus 10 times 90 would get us a cost of $950. Now, going the other way, how many times could we visit if we have $500 to spend? We would put 500 in as the cost. So 500 equals 50 plus 10V. We're trying to figure out how many visits we could get. So we're going to subtract 50 from both sides. 450 equals 10V. When we divide by 10, we get that V is 45. So we could make 45 visits to the gym.